Good morning, students. This online lecture, we will talk about design and analysis of algorithms. So, this is my third video in Unit 1 Design and Analysis of Algorithm. So, I have been given clear explanation and introduction of algorithms and the characteristics of an algorithms and pseudocode conversions in video lecture 1. In my second video lecture, Design and Analysis of Algorithm, so the how to calculate the time complexity and how to calculate the space complexity of a given algorithm. So with the help of the performance of an algorithm, so we discussed in earlier class. And this is the third session, third class in design and analysis of algorithm. So in this session, so let us talk about concepts. The first one is calculate the time complexity and space complexity of an algorithm. In different examples, let us discuss in this session. And also, we will discuss various types of time complexities and asymptotic notations. Also, we will discuss in this session. Asymptotic notations like Bigbo notation, omega notation, and theta notations we will discuss in this session. So, let us share the screen. So, this lecture will talk about space complexity, how to find out by the given algorithm, and how to find out time complexity, and what is meant by amortized complexity, and what is asymptotic notations, and what are various types of asymptotic notations we will clearly discuss about in this session. Students, so the question is, when an algorithm is said to be efficient and fast. The question is, when we can talk about an algorithm is efficient algorithm or an algorithm is fast algorithm. So this is the question. So another way of asking the question is how to measure efficiency of an algorithm. The answer is, if you want to measure the efficiency of an algorithm, it can be possible by using two factors. The first one is time complexity and the second one is space complexity. So whenever you are trying to compile an algorithm, it will take some time. For running an algorithm, it will take some time. For storing the algorithm in the system, it will take some space. So, time is one factor, another one is space is another factor. So, always the efficiency of an algorithm can be depends on the time complexity and space complexity factors. So, time complexity in the sense the amount of time required to compile and execute a particular algorithm is known as time complexity of an algorithm. So time complexity of an algorithm equal to compile time of an algorithm plus run time of an algorithm. So finally, if you add both compile time and run time of an algorithm, you will get the total time complexity of the given algorithm. Whereas space complexity this is also another factor for measuring the efficiency of an algorithm. So space complexity in the sense the amount of space, the amount of memory is required for storing the algorithm in the system. So how much memory will be occupied by an algorithm can be generate can be noted as a space complexity of an algorithm. So by considering the factors of time complexity and space complexity of the given algorithm, we can say how efficient the given algorithm is. So the algorithm speed, the algorithm fastness or the efficiency of an algorithm can be measured with the help of two factors or two properties, namely time complexity and space complexity. Now let us discuss the time complexity and space complexity in detail now. So firstly we will discuss space complexity. So the definition of space complexity is space complexity of an algorithm represents the amount of memory space required by the algorithm in its life cycle. That means that the amount of space or memory is required for compiling or executing an algorithm, for storing an algorithm is known as space complexity. So there is a formula here I can clearly specified for calculating the space complexity of an algorithm. So if you want to calculate the space complexity of the given algorithm, the formula is S of P equal to C plus SP. S of P equal to C plus SP, where here C is considered as a fixed part and whereas S of P is considered as a variable part. So what is fixed part and what is variable part of an algorithm we will discuss now. Let us consider a simple example algorithm addition of two numbers. So finding the space complexity of addition of two numbers of an algorithm, if you consider here, so there are various variables, there are various variables, namely a comma b, int a comma int b, c equal to a comma c equal to a plus b, and we are printing c value. So this is the way of writing an algorithm. Algorithm name and a comma b, c equal to a plus b. So that is the logic here. C equal to a plus b, that means that is an expression. So how much memory is required for storing c value, the variable c, it will take 1 unit of space for storing the value of c. So for initial, for storing A, it will take 1 unit of time. For storing B, it will take 1 unit of time. So totally, for storing three variables, namely A, B, C, each variable will occupy 1 unit of memory. So all variables are considered as a fixed part. These are considered as a fixed part variables. Why? Because each and every variable took only 1 unit of memory for storing the data in the structure. So this is considered as a fixed part. Okay. So whereas what is variable part? Variable part in the sense the size of a variable or the size of an expression cannot be constant. Cannot be constant. It may vary based on the situation. So let us talk about an example for loop. Consider a looping statement. Always the looping statements you consider for that it will occupy not only 1 unit of time, it will occupy sometimes n times, sometimes n square times, sometimes more number of times it will occupy. So it depends on the size of the I value. So in this case, the memory location for storing for loop is not constant. It may vary from situation to another situation. That's why it is considered as a variable part. So whenever we are planning to finding the space complexity of the given algorithm, remember there is a formula, note down the formula. S of P equal to C plus SP of I, whereas S of P stands for space complexity of the given program or space complexity of the given algorithm equal to constant variable length. The variable length, the variable constant length plus variable part of length. So this is the constant length, fixed part of length and plus variable part of length. Total will be, you will get one result. That result will be considered as a space complexity of an algorithm. So fixed part in the sense, so that a space required to store certain data and variables that are independent to the size of the problems. For examples, simple variables and constants, program size, etc. These are considered as a fixed part, whereas variable part is, it is a space required by a variable whose size depends on the size of the problem. It may vary. That means that the size of a variable may vary. Here the size of the variable is constant. Let us discuss a simple example with the variable part, dynamic memory allocation and recursion. In this case, the variable size is not a fixed one. It is may vary, depends on the situation of the problem. So space complexity formula is S of P equal to C plus SP. We already discussed in earlier size. S stands for, what is P here? P is an algorithm. Consider that P is an algorithm or P is considered as a program. And what is S? Let S of P, it is a space requirement for an algorithm. S of P considered as a space requirement for an algorithm or a program that can be calculated the sum of fixed space of an algorithm and the sum of variable space of an algorithm. So here C stands for fixed space and S of P stands for variable space. The space of the variable may vary from one situation to another situation. So now we will discuss how to calculate the space complexity of an algorithm with an example in the next slide. So friends, students, so let us discuss a simple example how to calculate the space complexity of an algorithm. So if you consider the algorithm, so this is the header part of an algorithm. Always the header part of an algorithm starts with a keyword called algorithm. Algorithm is the keyword and the name of algorithm is sum. The name of algorithm is sum, and here I am passing two parameter list, namely A and B. So the first statement of an algorithm is considered as a algorithm heading part. The first statement of an algorithm is considered as a heading part of an algorithm. So always it will take, the heading part of an algorithm can take 0 units of space. It requires only 0 units of space. That means that no space is required for storing the header part of an algorithm. So second one is, the second statement of an algorithm is open brace and the last statement of an algorithm is close brace. So open braces and close braces requires 0 unit of space. 0 unit of space. Open brace and close brace always requires 0 unit of space. That means that, so we are not allotting any space or memory location, memory for that open brace and close brace. So in between, meanwhile, there is a coding is, some coding is embedded in between the open brace and close braces. Now let us see how much memory is really required for storing the variables and for loops and arrays. We will discuss now. So now here I am assigning a value 0 to S. Here S is considered as a variable. So I am assigning 0 to that variable S. So the variable S requires 1 unit of space. That means that this is considered as a assignment or an expression. Always an expression can take, if you want to assign a value to a variable by using equal to, it will require 1 unit of time for storing. 1 unit of memory is required for storing. So whereas if you want to return the s, so how many times the variable is written? The variable s will be written only one time. The variable s returns only one time. For that also, S will require only one unit of space for storing. And whereas here, how many times this statement S equal to S plus A of I. Here, A equal to A is an array. A is an array and I value is gradually increasing from 1 to n. That means the value of I is initially 1 and it is gradually moved to n till. So if you consider an array A of I, so to store the size of an array, what now to store the array, here the size of an array or the array will requires n units of space for storing. So A of I will require n unit of times. Why? Because I value starting from 0 to n. That means that n unit of times it will be n units of memory is required for executing this statement for A of I. Whereas for S it will require 1 unit of time. So totally S equal to S plus A of I for executing the statement S equal to S plus A of I, it will require 1 plus n, 1 plus n number of unit space. For S, 1 unit is required. For A of I, n units required. Totally 1 plus n, that equal to n plus 1. So this third, this 1, 2, 3, 4, 5. This fifth statement requires n plus 1 units of time for storing the data, for storing the variable expression. And next one is for loop. So this for loop for I equal to 1 to n. So here the variable 1 will requires only one time storage and the variable n will requires n units of storage for storing the data in the database. And finally, now the question is how to calculate or how to find the space complexity of an algorithm. Now let us see. So space complexity of an algorithm is to be calculated. We can use one formula S of P equal to C plus SP. And here C is a constant part. C is a constant part. Here the variable S, I, N are constant parts. So the variables n comma s comma I, these variables will be assigned only one unit of time for storing. So total these will require one unit of time each. And this is considered as a constant space, whereas the array will comes under variable space. Why? Because the array size or the array memory location may vary from based on the value of I. And totally, so the time complexity of an algorithm equal to constant space plus variable space. Here the constant space is equal to total 3 and whereas the variable space is equal to n, and totally the space complexity of given algorithm is 3 plus n. 3 plus n is the total time complexity, total space complexity of the given algorithm. So friends, I hope you understood this concept. Now let us discuss the space complexity of an algorithm. So with some other examples later on. Now we will move to time complexity of an algorithm. So how to calculate time complexity of an algorithm? So to calculate the time complexity of an algorithm, so you can focus on two things. The first one is compile time. The second one is run time. So time complexity equal to the sum of compile time and run time of an algorithm. That is equal to time complexity of an algorithm. So there is a formula to calculating the time complexity of an algorithm. T of n, T of n stands for time complexity of given number equal to C plus RP. C is the compile time and R suffix P is the run time. So compile time plus run time. So here where is T of n stands for T of n is considered as a time complexity, C is a compile time and RP is called run time. So in this way we can calculate the time complexity of an algorithm. So now some while calculating the time complexity of an algorithm, so some number of steps we need to take consider here. Suppose let us take an example of an algorithm. In that algorithm, assume that there are 10 lines of code. Assume that there are 10 lines of code. And each and every line of code will took some amount of time. Each and every expression or each and every instruction of an algorithm can take some number of times it will be executing. You can calculate the time complexity, you can calculate the frequency, how many times each and every line of code in the expression in the algorithm can be executed. You need to calculate, and at the end you need to add the total number of frequency count, and finally neglect the constant values, will get the time complexity of an algorithm. So there are some guidelines while calculating the time complexity of an algorithm. If you consider an algorithm, the algorithm can contain comment lines. So if an algorithm can contain comment lines, the comment line will take zero amount of time for executing. So and runtime also. Assignment operator. If an algorithm can have an assignment operator or an assignment statements like equal to a equal to 10, b equal to 20, c equal to 20 plus 30. So these are some of the assignment statements. So these assignment statements will be executing only once at a time. Only once at a time. It will occupy 1 unit of time for executing or compiling the algorithm. And the conditional statements, if statement, else statement, these also one unit of time it will be required. And whereas the body of an algorithm will take n parts, and the loop conditions will take n plus 1 part. Loop conditions of suppose for example loop conditions in the sense for loop, for for I equal 0, I less than n, I plus plus. For in terms of algorithm, for I equal to 1 to n 2. So in this case, how many times the line will be executed, in the sense, if the for loop is true, it will be executed n times. It will be executed n times. If the statement is false, or if the condition is false, it will take one more time, and totally, if any for loop wants to execute, it will take finally n plus 1 number of times it will be executed. If so, in this way, we can calculate the time complexity of the given algorithm. So, let us see a simple algorithm for calculating the time complexity of an algorithm. So, here this is an algorithm. The algorithm total 7 lines of code will be visible to all of you. And here S or E, that means that how many number of times it will be executed. Each and every statement will be executing or not. If the statement is executing, it will take 1. If the statement is not executing, it will take 0. It will take 0. And frequency, in the sense, how many number of times each and every statement is to be executing, that will be mentioned in the frequency. And whereas the total number of steps will be finally, so the frequency will be considered as a total number of steps. This into this, there will be this frequency into execution, we will get the answer of total number of steps. Now consider the first statement or first instruction of the given algorithm. Name of the algorithm sum a comma n. This is considered as a header part of an algorithm. Always remember that if you want to execute or compile, the algorithm header part will take 0 times. The time complexity, how many times it will be executed? The first instruction will take 0. So total number of steps is equal 0. And opening brace, close brace never executed, it will take 0, 0, 0. And assignment of statements. This is an assignment based statement. Assignment statements can be executed only once. So S is equal to 0, it will be executed only once. 1 into 1, 1. And for loops, looping statements can be executed n times. If it is true, when the looping statement is to be false, it will take one more time, totally n plus 1 time. So for loop, the statement for I is equal to 1 to n. If you want to execute the statement, the frequency count equal to n plus 1. N is for loop true, and 1 is for loop false. And but it will be executed only one time. And S equal to S plus A of I. Here A is an array. The array will be executed n number of times. The array will be executed n number of times. The value of n may vary from 1 to n. So that's why the frequency is n. And return s. So when the result will be stored in s, we are printing the result or we are returning the value of the result. So we need to return the value of s very given variable only once. So the frequency count of return s equal to 1. So now we will add all these, zero, 0, 0, 0, 1 into 1, 1, 1 into n plus 1, n plus 1, 1 into n, n, 1 into 1, 1, 0, 0. And add all the total steps. Add the total steps here. 0 plus 0 plus 1 plus n plus 1 plus n plus 1 plus 0. And totally 2n plus 3. 2n plus 3. We got the answer is 2n plus 3. But now how to find out the time complexity of total of a given algorithm is here. This is the expression we got it, and based on the expression we need to neglect the constant values here. So what are the constant values here? Here in this in the given expression 2n plus 3, the constant values are 2 and 3. 2 and 3 are considered as a constant values. Neglect the constant values. When you neglect the constant values or ignore the constant values, only n left. Only n left. So that means that the final complexity of the given algorithm is order of n. T of n equal to order of n. So friends, in this way we can calculate the time complexity of any algorithm. Now let us see another example for calculating the time complexity of the given algorithm. So friends, this is the second example. So we will discuss about we will talk about how to calculate the time complexity of the given algorithm. So algorithm name is add, and we are passing 5 parameters, namely a, b, c, m, comma n. So this is the first statement of an algorithm. This is considered as a algorithm header part. Always algorithm header part took 0 number of times it will be executed. It will take the number of times. How many number of times this statement is to be executed? The first instruction in the given algorithm, it will take 0 times it will be executed. So the execution time is 0. So total number of times is 0. If the total number of execution time is 0, the frequency count no need to calculate. Obviously it will be 0. And the open brace and close brace, it will took 0 only. 0 execution time of open brace 0, and the execution time of close brace is 0, and those mentioned in the total number of steps also. If you consider the body part of an algorithm, there are two consecutive for loops. There are two consecutive for loops. If you consider the first for loop, line number, statement number 3, if you consider the statement number 3 in the given algorithm, for loop for I is equal to 1 to m do, for I equal to 1 to m do, and for j is equal to 1 to n do. These two are interlinked together. So for loops are embedded. The second for loop is linked to the first for loop. That means that there is an association between the third statement and fourth statement. So my question is here. The question is, so what is the frequency count of your statement number 3? The frequency count of statement 3. That means that how much time it will require for executing the statement number 3 for loop. So for loop will be executed. So if it is executed means once, if it is not executed means 0. So for loop will be executed. If it is executed means only one. I have mentioned here the frequency count. How many number of times the for loop will be executed, in the sense m. If the for loop is true, m times only. If the for loop is false, one more time. So total number of time complexity frequency is m plus 1. And for the second for loop, for j is equal to 1 to n. Actually, for j is equal to 1 to n, if the given statement is true, it will take n. If the given statement is false, it will take 1. So total frequency count is n plus 1. Statement number 4 took n plus 1, but the statement number 4 depends on statement number 3. So in this case, so totally, so it will require m into n. So m into n plus 1. this m into n plus 1 number of times it will be executed. The frequency count is m into n plus 1. And statement number 5, here we are adding two arrays. Here we are adding two arrays, array A and array B, and finally result will be stored in array C. So this is another expression assignment statement. This assignment statement will be executed how many number of times, in the sense A of ij, this is an array, the array will be dependent on m, and B of ij, this will be dependent on n, and total number of total frequency count is, for the first array is m and the second array is n, and totally m into n number of times it will be executed. The frequency count is mn. And finally you can add the total number of steps. You will get the expression as 2 into mn plus 2m plus 1. This is the final resulted expression. But from this expression, we need to calculate the time complexity. So before calculating the time complexity of the given algorithm, we need to ignore the constant values of the expression. What are the constant values available? 2, 2, 1. These are constant values. Ignore simply. If you ignore 2, 2, 1, then what is the revised expression? The revised expression is mn plus m. mn plus m. So here you can mn plus m is the expression. So in this expression, you always consider the highest coefficient value only. So which one is having highest coefficient value, mn or mn? Mn is the highest coefficient value. So ignore the least coefficient value. In this case, we are ignoring the least coefficient value m. So when we ignore the least coefficient value m, what is left finally? mn is left. mn is left. So finally, we need to calculate the time complexity of an algorithm. So based on the given expression, and finally we will get the answer is mn. So we will get the result of time complexity of the example 2 is mn. So we discussed how to calculate the time complexity of the given algorithm in previous slide. But what are various types of the time complexity? So basically the time complexity may vary in three ways. The first one is best case time complexity, average case time complexity, worst case time complexity. So these three categories will be depends on the speed of the computer or the speed of the execution and compile time of an algorithm. So if you got an answer in a first step, suppose let us consider a simple example. Bubble sort. In the bubble sort, initially there are some n number of elements. There are some n number of elements. All the elements are initially all number of given elements are sorted. In this case, what is the time complexity? That means that how much time is required and how much compile time is required and how much execution time is required is in the sense all the in the question itself, all the elements are sorted. And what is the result we are expecting? Sorted array. Already sorted array is there. How much time is required for executing this algorithm? One time. That is called as a best case time complexity. In a single step, you got the answer. Second scenario is if the elements are not sorted in the given problem, the elements are given randomly. The elements are given randomly. In this case, sort the bubble sort. Sorting the elements by using bubble sort, it will take either less time or either maximum time or either minimum time. But best time is not, we will not get the best time. Why? Because in a single step, if you got, then only it is considered as a best step. But in this case, it will took either average or either worst case. Maximum number of steps are required for sorting the elements, or average number of steps are required for sorting the elements in this case. Suppose if the elements are given in a highest value to the smallest value in a sorted, unsorted order, highest value to the smallest value. In this case, so if you want to sort those elements, it will take maximum number of times. It will take maximum number of times for executing the problem, for executing the algorithm. So in this case, the time complexity is worst case time complexity. Worst case time complexity. Let us see the example in bubble sort. When the input array is already sorted, that means that all the elements in the given array already sorted, the time taken by an algorithm is linear. So that means that only one step will get the answer. That is considered as a best case time complexity. But when the input array is in reverse condition, that means that the elements are not sorted in the order. The algorithm can take how many number of sorting elements, maximum time to sort those elements. So that is considered as a worst case. So another solution is when the input array is neither sorted nor in reverse order, then it will take average number of times. So these durations are denoted using asymptotic notations. That means in the sense, so the time complexity can be depends on the speed of the algorithm, the time speed of the algorithm. Sometimes the algorithm took maximum time, sometimes the algorithm took minimum number of time steps, sometimes the algorithm took average number of times for executing the algorithm. So based on the number of steps it will take for executing the algorithm, we can conclude that whether it will be a best case, average case, or worst case. So friends, let us move to the another important topic, notations. This is the last topic in this session. Notations, simply called as the asymptotic notations. Asymptotic notations. So what is meant by asymptotic notations? Why we really require this? We will discuss in this session now. So asymptotic notations in the sense, asymptotic notations in the sense. So let us talk about the definition of asymptotic notations. Asymptotic notations, when we will use, we will discuss now. So, analyzing the complexity of any algorithm. Once again, read out. Analyzing the complexity of any algorithm in terms of time complexity and space complexity. We never provide an exact number to define the time required and space required by an algorithm. That means that if you want to find out the time complexity, the space complexity of an algorithm, we never provide a simple number. We never say that this is the answer. So for measuring the time complexity, for measuring the space complexity, we cannot say the exact number. This is the answer, we cannot say. It may vary, depends on the situation. So instead of we express it using some standard notations, that notation is known as asymptotic notations. So the speed of an algorithm in terms of time and space measuring, it can be done with the notations that is called as a asymptotic notations. Friends, there are three types of asymptotic notations, namely Bigbo notation, omega notation, and theta notation. Namely Bigbo, this is the symbol for measuring, for noting the notation, Bigbo notation. And this is the second one is omega notation, and the last one is theta notation. So to Bigbo notation can support for upper bound, big omega, lower bound, big theta, average bound. So finally I can conclude that asymptotic notations are the notations which can be used for measuring the time complexity and space complexity of an algorithm in terms of variable number of notations. Now let us see the first notation, Big O notation. So what is mean by Bigbo notation? Students remember that the definition is very important here. So in examination also, you need to write the definition without any mistakes. What is big O, what is omega, and what is theta. So remember that big O notation is the first notation in asymptotic notation. So the big O notation, when we are using upper bound, always big O. This is used for upper notations, and whereas it will give the worst case time complexity. It gives the worst case time complexity. Why? Because the boundary is upper. That means that the boundary of is very large. If the boundary is upper bound, it will take many number of times. It will take maximum number of memory, maximum memory for storing or for executing. So whenever an algorithm takes maximum time, maximum memory, so the limit is upper, so it will take maximum time is required, and maximum number of time complexity is required, maximum number of space complexity is required for executing the algorithm. So in this case, it always comes under worst case scenario. Worst case scenario in this case. So definition is here. Let us talk about the definition. There are two functions here, namely f of n. F of n is function. F of n is the given function, and g of n. G of n is another function. Here the statement is f of n equal to O of g of n. That means that a function f of n is said to be big O of g of n. A function f of n is said to be big O of g of n. So the definition is, let f of n define runtime of the algorithm. Here f of n is the given function. The function define the runtime of an algorithm always. So friends, remember this definition. This definition is very important and useful for you while writing an examination. You should not do any mistakes while writing this definition. So the definition of Big O notation is, the function f of n is said to be big O of g of n if and only if and only if there exist all positive constants. There exist all positive constants. C, one constant is C, another constant is n naught. N naught is one constant, and C is another constant, such that the given expression is to be executed. What is the expression? F of n is less than or equal to C into G of n for all n is greater than or equal to n naught. That means that, see friends, students, here we can focus on the expression is, this is very important. F of n always less than or equal to constant value into g of n. Constant value into g of n. That means that which one will be in the upper bound? C into g of n is upper bound. C into g of n is upper bound, and f of n is less than or equal to. That means that the function f of n value is either less than or equal to C into g of 1. When this function is to be executed, when this statement is to be executed, obviously we can consider the given expression is big O notation, comes under big O notation. See here, so here we can start it, and it will be gradually decreased, and again the graph is increased and gradually decreased, and it will be going on increased, and finally stopped here. So finally, when you calculated here the range of f of n and g of n, f of n is below the range of C into g of n. That means that the function f of n requires, the function f of n requires many number of statements for executing. It will take more number of time complexity and space complexity. More number of time and space is required for executing an algorithm. So this is the definition of asymptotic notations, big O notation. So that means that f of n is below and C into GFN is upper bound. C into GFN is upper bound, and it will take worst case time complexity. Worst case time complexity. So these two, so yeah, C into GFN, this is the curve, and another curve is the thin curve is FFN. These two curves will be met at the last time is here. That will be marked as N naught. That will be marked as N naught. The curves may be vary based on their effective. When these will be met at the last time, that will be marked and that will be considered as a N naught. Okay. So once again, repeat the definition of Bigbo notation. The function f of n equal to c into the function f of n equal to big O of g of n if and only if there exist all positive constants c and n naught such that f of n is less than or equal to c into g of n for all n is greater than or equal to n naught. That is considered as a big O notation. Next, another notation is second notation is omega notation. The second notation is omega notation. The omega notation represents lower bound. Omega notation represents lower bound. Lower bound means the number of instructions for executing the program is less. The number of instructions for executing the given algorithm took less number of statements. So that means that the time complexity is best case time complexity. So omega, using omega we can find out the time complexity in the best manner. So coming to the definition of omega notation, given in the given graph there is a function f of n and another function g of n, and c is a constant value, n is a constant value, n naught is a constant value. So the function f of n equal to omega of g of n. That means that the given function f of n equal to omega of g of n ఎప్పుడు అంటామంటే if and only if there exist all positive constants c and c naught such that the given f of n is greater than or equal to c into g of n. That means that here the f of n will be the highest boundary and c into g of n is the lowest boundary. C into g of n is the lowest boundary, f of n is the highest boundary here. So that means that always the value of f of n is greater than equal to c into g of n. Here the boundary value of c into g of n is less than to the boundary value of f of n. So that means that, so this is just reverse to the previous one. Reverse omega notation is reverse to the big O notation. And third one is theta notation. In this theta notation, we are using two different constants, namely one is C1, another one is C2. So in earlier we are using one constant variable, but here we are using two constant variables, namely C1 and C2, and g of n is the function, and the f of n is lies between these two constant values. So the f of n function lies between C1 into g of n and C2 into g of n. So in this case, if this is true, we can conclude that the given expression and notation is theta notation. Theta notation is always used to balance or to find out the average ground. Why? Because f of n is average. It will be average. The term is average here. And thus it will give the average case time complexity also. And coming to the definition, the function f of n equal to theta of g of n if and only if there exist all positive constants. Two constants here, one is c1 and another one is c2 and n naught, such that f of n lies between c1 into g of n and c2 into g of n for all n greater than or equal to n naught. If the condition satisfies, we can conclude that the given notation is theta notation. If the function f of n lies anywhere between c1 into g of 1 and c2 into g of n for all n greater than or equal to n naught, then the given function f of n is said to be asymptotically tightly bound. It is tightly bound average. So here there are three different curves two are thin and one is thick. The thick line will be started here and these will be met here only. That will be considered as a n naught. Now friends, let us see the difference between big O notation, omega notation and theta notation in broadly. So if you consider the basic difference between big O, big omega and big theta definition, these are the various definitions. Observe that f of n is the given function equal to, and the symbol is vary here. Each and every definition, the symbol is different. This means that the given function equal to big O of g of n. ఎప్పుడు అవుతుంది? f of n equal to g of 1 ఎప్పుడు అవుతుంది? ఈ కండిషన్ సాటిస్ఫై అయినప్పుడు అవుతుంది. ఆ కండిషన్ ఏంటి? f of n is less than or equal to c into g of n. సో f of n అనేది c into g of n కి ఈక్వల్ గా అయినా ఉండాలి, లేకుంటే దానికంటే తక్కువైనా ఉండాలి. అలాంటి కండిషన్ లోనే బిగ్ ఓ నోటేషన్ అనేది మనకి వస్తుంది. సో అదే ఎఫ్ ఆఫ్ ఎన్ అనేది సి ఇంటూ జి ఆఫ్ ఎన్ కంటే ఎక్కువ ఈక్వల్ గా ఉన్నా, లేకుంటే దానికంటే ఎక్కువగా ఉన్నా అప్పుడు బిగ్ ఓ నోటేషన్ అనేది మనకి అప్లికబుల్ అవుతుంది. సో హియర్ టూ కాన్స్టెంట్స్ అంటే యావరేజ్ కేస్ టైం కాంప్లెక్సిటీ మెజర్ చేయడానికి థీటా వాడతామండి. సో ఎఫ్ ఆఫ్ అనేది ఎక్కడ ఉంటుంది? ఇక్కడ మిడిల్ లో ఉంటుంది. ఎఫ్ ఆఫ్ ఎన్ అనేది C1 ఇంటూ జి ఆఫ్ ఎన్ కి కంటే ఎక్కువగా ఉండాలి, C2 ఇంటూ జి ఆఫ్ ఎన్ కంటే తక్కువగా ఉండాలి. అంటే ద వాల్యూ ఆఫ్ ఎఫ్ ఆఫ్ ఎన్ ఈజ్ lies between C1 into GF1 and C2 into GF2. వాటి రెండింటి మధ్యలో ఉంటుంది కాబట్టి యావరేజ్ కేస్ టైం కాంప్లెక్సిటీ కనుక్కోవడానికి ఇది యూజ్ అవుతుంది. ఇది వరస్ట్ కేస్ టైం కాంప్లెక్సిటీ కనుక్కోవడానికి యూజ్ అవుతుంది. బిగ్ ఓ ఒమేగా అనేది బెస్ట్ కేస్ టైం కాంప్లెక్సిటీ కనుక్కోవడానికి యూజ్ అవుతుంది. అండ్ బిగ్ థీటా అనేది యావరేజ్ కేస్ టైం కాంప్లెక్సిటీ అనేది కనుక్కోవడానికి యూజ్ అవుతుంది. ఫ్రెండ్స్, స్టూడెంట్స్, so I am concluding this lecture now. So this is my third lecture. I hope you all understood the basic concepts of algorithms, time complexity, how to calculate space complexity, and how to measure the time complexity and space complexity in best case, worst case, average case also. So we discussed in this video. ఫ్రెండ్స్, మై సజెషన్ ఏంటంటే ద డిజైన్ అండ్ అనాలిసిస్ ఆఫ్ అల్గారిథమ్ సబ్జెక్ట్ అనేది చాలా యూస్ఫుల్ సబ్జెక్ట్ అని మీకు ఈ ఇంజనీరింగ్ లో ఏ ఇంజనీరింగ్ కాలేజ్ కానీ, ఏ ఇంజనీరింగ్ యూనివర్సిటీ కానీ, ఐఐటీస్ కానీ, ఎన్ఐటీస్ కానీ, ఏ ఆర్గనైజేషన్ మీరు తీసుకున్నా సరే ఈ సబ్జెక్ట్ అనేది కంపల్సరీగా వాళ్ళ కరికులంలో ఉంటుంది. ఎందుకు ఈ సబ్జెక్ట్కి అంత ఇంపార్టెన్స్ ఇచ్చారంటే గేట్ ఎగ్జామినేషన్ లో, ఏదైతే గేట్ ఎగ్జామినేషన్స్ కానీ మీకు ఏమైనా కాంపిటేటివ్ ఎగ్జామ్స్ ఉంటాయో వాటిలో 5 to 6 క్వశ్చన్స్ డెఫినెట్ గా ఈ డిజైన్ అండ్ అనాలిసిస్ ఆఫ్ అల్గారిథమ్ సబ్జెక్ట్ నుంచి ఇవ్వడం జరుగుతుంది ఫ్రెండ్స్. సో అలాగనే ఈ సబ్జెక్ట్ కి ఇంత ఇంపార్టెన్స్ ఎందుకంటే దిస్ ఈస్ ద కోర్ సబ్జెక్ట్ ఫర్ కంప్యూటర్ సైన్స్ ఇంజనీరింగ్ స్టూడెంట్స్. వై? బికాస్ యూజింగ్ డిజైన్ అండ్ అనాలిసిస్ ఆఫ్ అల్గారిథమ్ ఈ కాన్సెప్ట్ యూజ్ చేసి మన రియల్ టైంలో మనకు వచ్చిన ప్రాబ్లమ్స్ ని ఎయిదర్ ఇట్ ఈస్ ఏ స్మాల్ ప్రాబ్లమ్ ఆర్ కాంప్లెక్స్ ప్రాబ్లమ్, ఏ ప్రాబ్లం అయినా ఈ డిజైన్ అండ్ అనాలిసిస్ ఆఫ్ అల్గారిథమ్ టెక్నిక్స్ యూజ్ చేసేసి చాలా సింపుల్ గా సాల్వ్ చేసుకోవడానికి అవకాశం ఉంది. సో అందుకని ఈ సబ్జెక్ట్ అనేది మ్యాండటరీగా పెట్టారు. ఇది చాలా ఇంపార్టెంట్ సబ్జెక్ట్. ఇది మ్యాథమెటికల్ సబ్జెక్ట్ కాదు, అలాగని థియరిటికల్ సబ్జెక్ట్ అని కూడా చెప్పలేం. జస్ట్ అల్గారిథమ్స్ మిక్స్ అయి ఉన్న సబ్జెక్ట్ అనేది చాలా ఈజీగా ఉంటుంది. సో మీరు యూట్యూబ్ లో సెర్చ్ చేస్తే చాలా వీడియోస్ దొరుకుతాయి. ప్రతి కాన్సెప్ట్ కి డాలో మీరు కావాలంటే ట్రై చేసి చూడండి, బ్రౌజ్ చేయండి. టాపిక్ ని మీరు బ్రౌజ్ చేయండి, దానికి సంబంధించిన వీడియోస్ వస్తుంటాయి. మీరు నా వీడియో కాకపోయినా ఆ వీడియో అయినా మీరు చూడొచ్చు. బెటర్ గా మీకు ఏ వీడియో అనిపిస్తే బాగుంది అనిపిస్తే ఆ వీడియోని మీరు లైక్ చేసి ఆ వీడియోని మీరు చేసుకోవచ్చండి ఫ్రెండ్స్. సో దీని ప్రకారం మీరు పోతారనుకుంటున్నాను. థ్యాంక్ యూ అన్నమాట.